Now, some books will say if it's a negative charge, use your left hand. That's really not in favor of that. And so, if I'm doing a high energy experiment, and I have some target here, and I take a bunch of protons, and I slam the proton into this target, I'm gonna get a shower of particles coming out. I got so much energy built up into this, we get this mass energy conversion, or energy mass conversion, E equals mc squared. I get so much energy in this, it pops into this, I get a shower of particles coming out, and I have to somehow identify these particles. One way that you can do it is you send it through a magnetic field. This particle comes along, if it bends this way, well, let's see, if that's a positive charge, magnetic field going that way. If it bends this way, it's positively charged. If it bends this way, it's negatively charged. If I have two particles, both positively charged, and one bends like this and one bends like this, well, it's quite possible that they have different masses. This is more massive, so it doesn't bend as easily. And so you can start to narrow down what these particles are based upon how they behave. And it is possible to actually see this. The chemistry instructor who used to work at early college set up a tank. You just need a superheated fluid, which is, or superheated gas, no fluid, which so it's a superheated fluid, which could be gas or liquid. You want it, yeah, it's the water vapor, or whatever the vapor is. You have it so that it wants to boil, but it's not. This is different from what she set up. Sorry about that. When they originally were doing this, they'd get a superheated liquid, which means that you have it well above the boiling point, but there's so much pressure on it, it's not boiling. And just the smallest disturbance is needed in order to get it to show signs of something. And so as a particle would go through this superheated liquid, bubble trails would form. Now you get something similar, not with a liquid, but with gases, with gas and, I forget, rubbing alcohol and dry ice. I'd have to go back and look again. Anyway, she had it set up in essence, an aquarium. And you could see as cosmic particles came through, you get these little trails coming out. And if you're exposed to a magnetic field, you can curve them.
I'm sorry, I missed the part where if it's shorter, what does that mean?
If there's basically a mass to mass to charge ratio that you would get based upon the curve here.
Okay.
And so based upon the radius of curvature, you can start to narrow down what type of particle it is. And then when it gets something that doesn't match anything, you potentially have found a new particle. And you get published and you can get bragging rights on that thing that nobody has actually seen. We've just seen evidence of its existence. And that used to get published into this 2,000-page manual of all the particles. Yeah. I think on that note, tomorrow is the test. Either we can here or there. One of those two places, or just spread out, use the hallway and take over. I do not. I've gotten away from the multiple choice more and more over the years. Just, oh, thank you.
I did it, but it's just blank for some reason. Do you want me to redo it?
stop recording, assuming it's still going.